All right, folks, we are going to get started into the next section, 4-2, which is titled Your Favorite Quadratic Equations. I know just when you thought it was safe and we were done with them, we are never done with them. Everything we do with polynomials is meant to get them back to quadratics, and we have to know how to solve them once they're quadratics. So we're going to revisit quadratic equations solving one more time. And I'm just going to jump right in. We are going to start, of course, this is all about solving quadratics. And we're going to have three methods we're going to use. First one is factoring. Again, guys, this is our last chance that we have to master this whole thing of solving quadratics. So let's look at a couple examples. First, 3x squared minus 12x equals 0. Now, I want to mention a couple things we always need to do anytime we're given a polynomial of any degree. Is if we're asked to solve it, we need to move that all the terms of that to one side and set it equal to 0. This already is set equal to 0, so we're good to go. But I just want to mention that as one of the first steps in this process is always going to be moving everything to one side, set it equal to 0. Then we have a chance of solving that polynomial. All right, so then the next step is always common factor. Is there a common factor here? Well, look, there is. If I look at these two terms and I look at the numbers 3 and 12, well, there's a common term of 3. So we'll take that out. We're going to divide that out. If I look at the variables, there's an x squared and an x. So there is a common x term in there. Now we make our open parenthesis and we divide 3x squared by 3x. That leaves us just an x, right? The 3's cancel and one of the x's cancel, leaving us just an x. Then we do the same with 12x. A negative 12x, 12x divided by 3x. The x's cancel. This cancels, leaving a 4, so we get negative 4 equals 0. We've got this in factored form now. There's nothing I can do with this or this to make it any further or take it any further. So now we look at the idea behind factoring is if I have things multiplied and equal to 0, each one of those could be equal to 0 to make that true. Because if this term is 0, then this whole thing is 0, right? When we multiply. If this term is 0, when I multiply it about whatever this is, it would also be 0. So we just set each one of them equal to 0. And find what makes those true. So we have these two things where we find if 3x equals 0, that means dividing everything by 3, x equals 0. Here at 4 to each side, x equals 4. There's our two solutions. All right, so let's do one more. This is again factoring. We're solving through factoring. And let's do this one. 3x squared minus 10x minus 8 equals 0. All right, so when we look at this first, always, is there a common factor? 3, 10, and 8? Nope. X squared, x, no x. Nope, not there either. So now I use magic, all right? This is the way I approach factoring. I think it's one of the easiest things I've ever seen in terms of factoring. Factoring is not easy for everyone, but this is one of those ways that always works, and I like it because of it always working. It's not a gimmick for just certain types. So 3 and negative 8 multiply to negative 24. All right, so first step in that is multiply A and B. When I say A and B, I'm talking about factoring a quadratic that's in this form, right, where ax squared plus bx plus c equals 0. So I multiply A and B and I get negative 24. Now I need factors of 24. I'm going to say it as AB, whatever A times B is, that add to C. All right, so I need factors of this. 1 and 24 are factors. I'm looking for factors that could add to 10. 2 and 12. Well, add or subtract, I should say, because we had a negative here and we're trying to get a negative there. If we have a negative here, one's positive, one's negative, so we can talk about subtraction as well. Let's see. So we've got 2 and 12. We want them to add to negative 10. So I'm thinking that's a positive 2 and a negative 12. Those will be our factors. They multiply to negative 24 and they add to negative 10. So we have those to work with. So with positive 2 and negative 12, what I'm going to do next is create two parentheses. These are going to be my binomials. I'm going to put in whatever was here, but not squared. All right. So we start to fill those with that. Then we take our two terms, plus 2 and negative 12, we put them in. Now this is where the magic comes in, all right? This is where you take your magic wand and, well, that's not a good magic wand. We'll just get rid of that. I was trying to draw one, but I don't know really how that would look. Anyways, you're going to wave that magic wand to make anything disappear that is a common term in that binomial. So 3x and 2, no common terms. There's nothing that goes into both 3x and 2. So that one stays the same. All right, then 3x minus 12. There is a common term here. It's 3. 3 goes into 3x. I'm going to make that common term of 3 go away. And this is where the magic comes in. I'm not factoring it out. I'm just dividing it out and making it disappear. This, again, between 3x and 12, the common term, the common factor was 3. So I'm dividing each one of these by 3, and I get this. Now, I look at this. This is factored form. This 3x times x gives me 3x squared. Outside would give me negative 12x. Inside would give me positive 2x. That makes my negative 10x. 2 and negative 4 make the negative 8. So this is my factored form. Now, I would set each of those pieces equal to 0. So that would mean 3x is equal to negative 2, and x equals, move this up a little bit, x would equal a negative 2/3. That's one of our solutions. And we look for the other one where x minus 4 equals 0. So x equals 4. And we have our two solutions for this quadratic. All right, let's keep moving. Next, solving by completing the square. This was everyone's favorite. I know when we did it before, and I am being facetious there. I know some people struggled with this, so let's take a look at it. Let's do one like this. Let's say, for example, you were given 2x squared minus 4x minus 3 equals 0, and you're asked to complete the square. All right, first thing I always do is I move this over. So I'm going to make room by doing this. And these first two steps are kind of interchangeable, so I am going to show them as step 1 and 2 because it doesn't matter which one you do first. Move the C term over. All right, that's the first step, or the second. Doesn't matter which way you do it, guys. The next thing is make sure A is equal to 1. All right, and again, you could do this in any order. Right now, A is not equal to 1, right? Our A is has a value of 2. We got to get rid of that. So we're going to divide everything by whatever that is so we get it to be 1. So 2 divided by 2 is 1. So this is now x squared. 4 divided by 2. This is now 2x. I have nothing there. This is 3 halves. And it's going to just stay 3 halves. Now we need to find our new C value. When we find our new C value, the way we do that is take whatever's here, divide it by 2, and square that. So 2 divided by 2 is 1. 1 squared is 1. So I'm adding 1. To do that to both sides of any equation because we have to balance the equation. So now on this side, I have something that is a perfect square. That's why we dealt with all that idea of what a perfect square looks like. I take the square root of the first term, square root of the last term, and I use this symbol between them, and it's that squared. So now that equals, and I'm going to erase this blue line because I don't want you to think we're dividing by this thing. This was how we found our C value. So I'll label it as thus. So C equals that. And this side, 3 halves plus this, I'm going to think of as 2 halves. That's 1. So 3 halves plus 2 halves is 5 halves. And I would have 5 halves here. And now I can solve, right? So what do we got? Let's see. We got to take square root of both sides. Take the square root of each side. This side, I get x minus 1. This side, I get the plus or minus root 5 over root 2. Now, we can't leave it that way, right? We can't leave a root 2 in the bottom. So I'm going to multiply top and bottom by root 2. And when I do that, I get plus or minus root 10 over 2. On this side, I still have x minus 1. So now I'm going to add 1 to each side. And when I do that, I am going to have x equal to 1 plus or minus root 10 over 2. Now, I would accept this answer, but I think it's better if you think of this as 2 over 2 plus or minus root 10 over 2. That way we can write it in a little nicer form as 2 plus or minus root 10 all over 2. And that would be the finished form of that solution. Again, completing the square. Let's do one more. I didn't want to extend. I want to go to the next page. All right, one more example for completing the square. Let's see. Let's do. Okay. Let's do this one. We have 2x squared minus x minus 15 equals 0. And again, we're trying to solve this using completing the square. So again, let me do it the other order this time, just so you can see. It doesn't matter which order you do this. I can divide. I don't have 1 here, so I'm going to divide everything by 2. And I would have x squared minus 1/2 x minus 15 halves equals 0. And now I can move this over. Again, just changing the order of those first 2 steps, it does not matter. Like I said, we'd have a positive 15 halves over here. And now we take half of this. What is 1/2 of 1/2? Well, 1/2 over 1/2, or over 2, is dividing it by 2, right? That would equal 1/2 times 1/2, which is 1/4. And then we have to square that, right? Half of a half is a quarter. A quarter squared is a 16th. That's what we're adding to each side. This is our C value. So I'm adding 1/16. Again, I'm giving you ones that are a little more advanced, guys, because I want you to see as ugly as it can get. And completing the square still works. So we're adding 1/16 to each side. This side then becomes x. The square root of that is 1/4. And I use the minus again. So we get that on this side. This side is, instead of 15 halves, I'm going to think of that in terms of 16ths. I have to multiply top and bottom by 8. So in 16ths, this would be, was it 120 16ths? So we'd end up with 121 over 16. Now, next step is to take the square root of both sides. And, whoa, got a little bit of a runaway pen there. All right, sorry, take the square root of that side. And this side becomes x minus 1/4. This side becomes plus or minus. Square root of 121 is 11. Square root of 16 is 4. So we get plus or minus 11/4. Add 1/4 to each side. Whoops. My hand's just doing what it wants to at this point. Plus 1/4. And we get x equal to 1/4 plus or minus 11/4. And again, that form would be fine, but I think it's easier to see if we do it this way. I shouldn't say that would be fine as a solution. What we're going to be doing is actually adding those and subtracting those. But I was going to say you could also write this as 1 plus or minus 11 over 4, which would give us our solutions, I think, in an easier way to see. 1 plus 11 is 12/4. That's 3. And 1 minus 11 is negative 10/4. So let's do this. 1 plus, oh, let's do this. I want to do it where you can see it on this page. 1 plus 11 over 4 equals 12/4, which equals 3. And then 1 minus 11 over 4 equals negative 10/4, which equals negative 5. Whoops. Negative 5. All right. So the other answer down here would be negative 5 over 2. All right. Do this. Okay, so we get 3 and negative 5 halves again by completing the square. What's next? Last thing, as always, is the quadratic formula. It's our last resort. When we get something, quadratic formula, we get something that we can't factor or use completing the square for, we can use quadratic formula. And you will be asked to do all 3 of these, so make sure you're able to do all 3. And let's look at another one. Let's look at, did we do this one yet? I think we did, but let's just do it again. Let's do x squared minus 4x plus 7 equals 0. Remember, quadratic formula tells us that x equals negative b plus or minus the square root of b squared minus 4ac all over twice a. And I want you also to remember that I showed you before, and they're going to ask you to do this again in this unit, that we look at the discriminant first. when I use quadratic formula, I find the discriminant first because it tells us what kind of roots. And they'll ask you those questions just like we did in the previous unit. So when I'm doing this, when I want to find the discriminant, first thing I do is label what is my A. In this case, it's 1. B is -4. And C is 7. So now I know I can find B squared minus 4AC first. B squared would be 16, right? Minus, that's -4 squared is 16, 4 times A times C. So that's 16 minus 28. So what is that? -12. So the negative number tells us what? If it's negative, if your discriminant is negative, then we know we have 2 complex roots. That's our case here. If it's positive and greater than 0, then what do we know? If it's positive and greater than 0, then we have 2, let's see. Well, we have 2 different possibilities there. I'm sorry, I jumped ahead a little bit. If it's greater than 0 and it comes out to be a nice square, we can have 2 rational roots. If square root is rational, in other words, if you can get rid of the square root, or we can have 2 irrational roots if they stay square root. All right, and last, if it's 0, what do we know? If that discriminant is 0, then we know we have 1 rational root. So in this case, we've got 2 complex roots. Again, the idea of 2 rational roots is, say we get something like square root of 16. That equals 4. That is the plus or minus 4, sorry. When we did that square root, we'd get that. So 2 irrational roots would be something like square root of 8, where we know that is going to be 2 root 2. This would be 2 irrational roots, just to touch on that a little bit more. All right. So what do we got? We've got -12. We know when we take the square root of -12, and I always do this ahead of time when I'm doing quadratic formula, this is going to be, I know there's an I because of the negative, and I know this is 4 times 3. So I know I'm going to bring out a 2 for the square root of 4, an I, and a root 3 is going to stay. So that's 2I root 3. Now I can do my quadratic formula easily because x is going to equal -b. So the opposite of b is -4, so that's going to be 4, plus or minus, I already know what my rest of that is up there. It's 2i root 3 all over twice a, which is 2. So I can factor the top taking a 2 out and leave 2 plus or minus I root 3. And that's a 2 on the bottom. Those cancel. So my solution would just be 2 plus or minus I root 3. We have our 2 solutions for that using quadratic formula. Again, they could ask you to find the discriminant value. Like in this case, the discriminant value was -12. And they could ask you then what was the number and type of roots. That is 2 complex roots. And that does it, guys. That's what we're doing for 4.2. Again, hopefully this is a review, and this is a nice section just to get your head back in quadratics and get ready for that. We are going to be using this throughout the chapter, so be ready for it. Have a great day. See you soon.